Our next example, we want to find the absolute extreme of f of x equals x to the 2/3 power on the interval from -1 to 8. So again, I just have it sketched out for you. You don't have to do the graphs, but I thought it might be a little bit more helpful when you're first working through these so you can see what these actually look like. So again, first thing, step 1, is we have to take the derivative. So x to the 2/3, that 2/3 gets multiplied out front, and then subtract 1 from the exponent. We get f prime of x is 2/3 x to the -1/3. So the only critical number, which is what makes it undefined, is 0. Because if I were to rewrite it, it's 2/3, sorry, my pen is smearing over here, times 1 over the cube root of x. So the only thing makes it undefined is 0. So we're again plugging in into this original function, 0, and then our endpoints of -1 and 8. So 0 to the 2/3 is 0, -1 to the 2/3 is 1, and 8 to the 2/3 power is 4. And if you forget how to do this, you can plug it in your calculator. Just use the fraction key as an exponent, but the bottom number is the root, and the top number is a power. So cube root of 8 is 2, 2 squared is 4. So my absolute max is going to be at 4, and my absolute minimum is at 0. And you can see that very clearly from the graph. So there's a couple optimization problems that I wanted to go through with you. For the applications, and there are tons of applications for this. You'll see them engineering-based problems. I just picked a manufacturing and model bracket problem to go through with this, but the thing with optimization problems is you're always trying to optimize something. So you're either trying to like maximize a profit, or maybe if I'm doing an engineering product, I'm trying to minimize the cost. But the steps are the same. You're going to take the derivative and then evaluate it at the endpoints if you have endpoints. Sometimes you don't. But if you do have endpoints, you're going to evaluate it and see what gives you either the maximum or the minimum, depending on what you're looking for. So I would want to minimize costs. I want to maximize profits. So we have a manufacturer sells X units of a speaker system, and this is the profit function. So P of X is negative 0.02x squared plus 300x minus 200,000. And we're given this time it's between 0 and 20,000. So they can make no units at all, but the maximum they could ever make is 20,000 because of constraints of space and time and money to buy materials, things like that. So taking the derivative, we get negative 0.04x plus 300. When you set that equal to 0 and solve, we get x is equal to 7,500. So I'm going to evaluate it. P of 7,500, again, back to the original profit function when you go to do that step. And then I'm going to do P of 0 and P of 20,000. So the 0 and 20,000 were the endpoints here. When you evaluate it at 7,500, we end up with 925,000. Evaluated at 0, we get negative 200,000. And evaluated at 20,000, we get negative 2,200,000. So it's not in our best interest not to make any, right? Because you already have cost associated with it. So you're definitely losing money. And if we make too many, the cost that goes into producing these units is not even worth it. So you're not going to get all your money back out of it. So in order to maximize our profit, then we need to produce and sell 7,500 units, and that gives us that $925,000 profit. And then here we have a model rocket has been launched. T seconds into flight, it's given by this equation, negative 1/3 t cubed plus 4t squared plus 20t plus 2. And all we're given now is t is greater than or equal to 0. So we have to figure out what the derivative is and find those critical numbers. So taking the derivative, we get negative t squared plus 8t plus 20, and then I have to set it equal to 0. I factored out that negative value because I can't factor when there's a negative. So my first step was to think of it like that, and then I go and factor it, and it factors to t minus 10 times t plus 2. So when we solve those, we get 10 and negative 2. This is a nonsense answer. And the reason it's a nonsense answer is because we can't go back in time 2 seconds. Now, the next part is to evaluate that at 10, because that's the only value I have. And at 10, when you plug that in there, we get 268.6667, and they wanted to know to the nearest foot, so that's going to round off to 269 feet. Now you can evaluate that as 0, but when you plug in 0 into this thing, you see it's 2. So it was 2 feet off the ground when it was launched. So that's why I didn't even bother plugging that in.